All right, all right. So today I'm going to talk a little bit about um, some of the work that we've been trying to do to understand how people are interacting with Slurm uh, with respect to QPUs, and some ideas that well, this is scope work. I'm going to be talking about work that is not in Slurm yet. We don't normally do this, but it is scope. We are going to be releasing the features that I've written down, but in some spaces, not exactly as I would like. There's still room to make little adjustments. So what I'm trying to do today is I want to sort of go over what I think I understand about how the community is interacting with Slurm, and then I'm hoping that you'll tell me where I got that wrong, so that we can make sure that what we did know is right. And I think there's one thing I do want to say is that what we are building in is very generic in its scope. Our goal is not to over-index to any one thing, this area, but indeed a lot of the areas that we were talking about integrating this way are moving so quickly that we really want to build tools that enable the communities themselves to build what they need, if that makes sense. That's the bias from which I'm coming. As I look at it, there's sort of a number of problems that people are trying to solve when they're integrating with Slurm or with their supercomputing facilities. You know, first off is the user interface, some way of saying, I want a QPU and I want it to look like this. Then actually scheduling. You know, which user is going to get it for when and how long? There's been a lot of discussion today about authorization. How do you determine who gets to use it, how you're actually going to talk to it? There's interacting with the QPU, there's tearing down QPU usage, and then there's ensuring that we don't get jobs running. So and then of course there's overall orchestration of a work. These seem to be the major requirements. There's lots of details within. Stefano helped me get this together. This is a real-time post that mostly seen in the NVIDIA slides related to QPUs, but I've also started to see it around, I think, in general. So one of the big questions that I was bringing before is, if we're thinking about Slurm, one way to think about Slurm is imagine we have a controller out here. I should have put it in, but I didn't. On all the compute nodes, there's a Slurmd. This is our resource manager. This allows us to launch jobs directly on. Some people sometimes draw a Slurmd over here. And that has some interesting advantages to it. It would make some kinds of integrations with Slurm very, very tight and deep. And we can talk about how that would work. I think it has some trade-offs too, which is that it may bring in a lot of other requirements. So that's one of the central themes, you know, that people can think about is how tight should integration with the workload manager be versus how far at arm's length should it be. We are going to be talking about a plugin structure today. So I am including some details. We'll be coming back to this for now. I just want you to think generally about as a plugin sort of interface with the job.
I think you were going to talk more about Slurmd.
I will.
Just ask a quick question there.
Yeah.
Since it's not really running on the QPU or the controller, what does it matter where it runs?
Well, so it matters a lot in that once you bring a Slurmd there's suddenly a ton of site configuration that needs to happen. So if you push one there, now you've got to get the keys for Slurm there. You probably need to get the same file systems. If they're using a common file system, you probably need to get that there. It may have networking constraints. So it really becomes a part of the supercomputer at that point, depending on how tightly the administrators. I gotta tell you, if it was, if you brought something to my facility when I was a sysadmin and you said, okay, and now we need a whole bunch of these secrets from you, and you're gonna put them, and we're gonna put them in this thing. I said, no. That's not how this is gonna work. Now that's part of my network. That's part of what I'm managing, right? So it changes the conversation quite a lot. So basically the question is this appliance built for the good purposes of the QPU and its management stack, or is this part of the supercomputing software stack? I think that's an important distinction to be made. And it also gets at, should you have a slingshot NIC in it? The answer might be no, but anyway. Okay, so we're going to be talking about a plugin infrastructure. At some point, I'm going to be decorating this chart more with some of the integration points that we're thinking about making available. But it's pretty detailed what happens when a job starts, and so I thought it was good to just write it down so people can actually see it. And yes, it's very intentional that the QPU is a black box because that's how I want to view it. But so generally, this slide isn't going to talk anything about the QPU yet. This is more staging us for later. But when a job comes in, it'll get queued, and then eventually we'll decide to schedule it. That scheduling loop will sit there until it finally has resources that match all the criteria to run. You get this little space in some of our plugins called pre-run. This is actually after scheduling, but before we actually tell any of the nodes that you're getting this job. That's an important bit for later in the discussion. Then we finally do node allocation. At the same time, we run all the prologues. So if we have a controller prologue on the system and we have node prologues, those all run together. Once all the prologues complete, then we will launch a job script. You can run srun, and that goes through a whole bunch of steps, eventually actually running the task finally. And then finally, we get to tearing down the job. The control of the epilogues and the node epilogues run simultaneously, and the job ends after all of that's done. Anyone that's ever used Slurm probably eventually got stuck completing node. That means that something failed in that step kill. It's usually because of a bad node. Never a bug in Slurm. Okay, so here is what I have seen of the current challenges. Number one, there is a clear pattern emerging, which is that people are using licenses for scheduling, with one mention of Grez. We'll talk about that in a few minutes. And then Spank for UI and job integration. This means that there are multiple integration points and multiple configuration points that somebody has to engage in order to make this work, not a single integration point. Next, there's no clear way for the community to standardize any kind of a tight integration with Slurm based on this, because there's no, like I said, there's multiple points. People end up having to do complicated request syntax. It's like saying, I want a license for a QPU. Oh, and I'm going to now use these Spank arguments to give more options for the QPU. If I buy multiple QPUs and all the people that wrote a Spank plugin decided to use the string -minus QPU, now they're totally deadlocked and the site administrator can't do anything. So there's trouble. These are some of the things I was worried about. Spank plugins in general are incredibly complex to distribute, maintain, and manage. This also counts once you've finally given the site your hard work to have a Spank plugin. Now they have a thing that they have to file. You can't link it because you'll be violating the GPL2 if you do that. If you link it to any of your proprietary libraries, because it's going to be GPL2, you're going to validate all your patents. It's going to get very, very exciting. Don't use Spank. So I'm trying to give an alternative to the C-based linking that we also have to do. But also because it gets linked, now you can't, the site administrator, and because Spank integrates at every single layer of Slurm, now there's no way to do a rolling upgrade of Slurm. Because you can't, the controller and the CLI and the Slurmds, they all have to end up running the same linked code when it comes to Spank. And so that we have to take the whole system down. Now you can upgrade the Slurm, turn it back on. Remember that you didn't recompile Spank. Recompile Spank, redeploy Spank. Now you get to use the computer again.
Wait, why are you using Slurm?
Slurm, this is a Spank issue. and so okay. So these are some of the issues. And also the other sort of frank reality is that because of the hugely popular wide distribution of Spank, we can never touch the interface again. It cannot be iterated on. It can't be updated. We can't take any new requirements because it will break something somewhere for someone. So my personal suggestion is leave Spank to the site administrators and vendors stay out. That's my strong suggestion because there's just so many issues. All right, so let's think a little bit about what are our scheduling requirements. There's different kinds of scheduling. I'd love to hear about more kinds of scheduling, but the key things that I have heard in talking to various people is there's either mutual exclusivity. You want one user at a time using the QPU. or you want N people at a time using the QPU with some kind of biasing, and you're going to use some sort of internal scheduler to work out how the time show goes. The people that want one at a time have a belief that jobs will run from an hour to 30 days. The people that want time sharing have a belief that the jobs will run for 30 microseconds. Okay.
Right.
So we got to support both. The cool thing about time sharing is that enables more of an accelerator-like usage of a QPU. The cool thing about dedicated access is that now we're going to assume full occupancy of the QPU for the whole time your job is running. Another important aspect of scheduling that's came up in some of the earlier talks is that usage really does feed back into priority. So we have to get proper billing and accounting and whatever flavor is most adequate so that we can then feed forward into fair share. Because that's a critical capability. All right, so we have a lot of different scheduling resource models at Slurm. And I'm not going to go in detail through this, but I left it there because I think it's useful information. But the key thing to see here is that we're going through the smallest part of the system to the largest part of the system in this diagram. And so if we think about consres, this is our consumable resources, this is CPU and memory. It's really cool in that it allows the same node to be shared. We can oversubscribe or keep things mutually exclusive. And you're able to get detailed scheduling across the entire system. GRES offers a similar thing, but this is really only for on-node resources. That is the scope of the GRES. If you say, I've got 1,000 nodes and they all have this GRES on it, if that was your only scheduling target for it, now you can run 1,000 instances with a QPU, but there's no way to block it. And so you can maybe say, well, that node has the QPU, but if that node fails and you want mutual exclusivity, now you've got to reconfigure some of that node fails. So GRES isn't a great fit, but it's nice because it has plugins. So you can write code for it. That's cool. Hierarchical resources is kind of weird. I put it here for a reason. This is our evolution of licenses. I'm going to talk about licenses last for a very specific reason. But this is a new way of thinking of having an arbitrary topology of things that are schedulable in your system and being able to map how those things relate to nodes. Now, to some level, we can easily just say there is a count of one, just like a license, and every node in the system has it. But another cool thing you could say is, well, what if I had a better network connection on one rack to my QPU? And so I really only ever wanted this one rack to schedule out QPU jobs. Well, now I can just say in my hierarchical resource, this resource is available on this rack of nodes, and there's still only one of them. So you get the opportunity to define, and you can also invent hierarchy in deeper levels. So I don't want to speculate on the ways that I don't want to speculate too far. But I would say that some of the dynamic selection criteria that people that you were bringing up, that might become possible with certain ways of configuring and building out HRES. So these are some of the capabilities within HRES, but it's scoped to the cluster. So that's a cool thing because now I'm saying that this is a cluster attached resource. It's not a node attached resource, but maybe there is a node biasing to it, but it doesn't scale beyond the cluster. Then licenses. Licenses are also a cluster-wide resource. A better term for it, I always loved, well, I didn't love them because it's hard to use. I'm not trying to, I'm as a user of Grid Engine, but I love the term global resources. Global resources is exactly the right way of thinking about what licenses are in this case as well. License is just a legacy name at this point. But the concept here is we have some integral number of a thing. And that is a great fit for a QPU because it's not a node resource. It's not a software license either, but there are a certain quantity of them. If you want to do mutual exclusivity, you set the limit to 1. If you want to do time sharing, you set the limit to something bigger. You could even get your users to say, well, I want 60% of the QPU, and so they ask for 60 out of 100. The other guy wants 5% and 5 out of 100, or however you want to balance that. Those might be interesting models for how you communicate through the various device management layers to bias whatever sort of detailed, fine-grained accounting there is on the system. So that gives us a lot of flexibility. But in preparing the slide, I remembered something really interesting, which is that licenses don't need to just be on one cluster. You can have, if you share some DVD across multiple Sun clusters, you can share the licenses. So you could attach your QPU to 50 clusters. Now that might get chaotic and insane, but the point is that there is a multi-cluster operation through which you could now manage this. Now HRES doesn't go that far, but like I say, HRES is our evolution of licenses. So maybe at some point that becomes an interesting requirement that we think about. Like, how does that work? How do we externalize an HRES? I don't know the answer to that, and I'm not promising that right now. It's just I wanted to point out that licenses give you a tremendous flexibility.
Right.
Go ahead.
Yeah, I'll just say, from our perspective as well, I mean, license scheduling is a really powerful thing. There's a lot of history and solutions around getting really great sharing and multi-cluster utilization, quota control, a lot of cost. You know, for certain industries, licensing is the cost dominating feature.
Yep.
So that's UADA. Yeah.
So yes, and yes, you can do backfill planning around licenses. You can even do preemption around some kinds of licenses. So there's a lot of scheduling flexibility here. So
You had a line in your previous slide, no plugin.
Where?
Under HRES?
Yeah, we don't have a plugin today. We don't have a plugin tomorrow. Not literally tomorrow, like the Disney Tomorrowland.
Oh, that's good. Oh,
Yeah.
Okay, good. I was gonna say that's kind of a
No, we don't have
limitation.
we don't have them today.
Okay, got it.
And so if we think about what is the right place for QPUs, cons res is clearly not right. I would argue that res is probably not right unless you decided you wanted to dedicate some nodes. Then I think res is maybe great, but it doesn't meet all of our other requirements. HRES is the right layer. We do have billing weights that you can already use today for it, but it's using allocated time. So it's awesome for the mutual exclusivity model. I took this time away from everyone else, therefore I get billed for the full weight of it. That makes a lot of good sense. Again, licenses are fine, but we're hoping that over time we replace them all with HRES. Okay, so we're going to start building a plug-in system for HRES. The key thing here is that HRES has this great ability to model all kinds of arbitrary shapes tied to the topology of your system. That's cool. But there's no ability to communicate with the outside world. So that is fundamentally what we're going to be doing with this. Also, why Lua? People find Lua an interesting choice. It had a huge, great history with Slurm. The reason for that is that it's a simple and fast language that fits really well in with C, and it fits in really well with our locking strategy. And it really builds on your user base's World of Warcraft experience, which is the only other major place that Lua is used. But I'll add it now. But the nice thing here is that you just get, if you write your plugin and you hand that off to the sites, it's a text file. So if they need to edit it, they can edit it. If it's not, it won't in any way link against things. So it's not a GPL issue anymore. And it's a single point of configuration. Go ahead.
Lua has pretty, it's not as rich, right?
I mean, there's a tremendous set of libraries you can pull in.
Yeah,
So-
but you had to pull in the libraries.
You do.
Okay.
But
Okay, fair.
yeah, I agree with that statement. Okay. But in terms of the code, it's a very simple and straightforward deployment. You know, it's going to be hard for administrators to get too worried about it because they can easily examine all the code. The code can be itself quite simple. And in the past, we have gone through dozens and dozens of Sun versions without really in any way negatively impacting some of the interfaces that we build on Lua. So we can add things into the tables without changing what existing scripts are able to see into it. So the important thing is getting the right sort of spec for the function up front but we can inject a lot of things over time. Yep.
I feel comfortable the system in part includes the Lua with a lot of modules being imported, or is it pure like Lua standard, whatever it is?
Well, I mean, I would imagine that anyone that's doing this is likely going to be pulling in, unless they all want to write their own HTTP implementation, then they're probably going to pull in some
That's always
set of things.
The comfort zone, that's what.
That's what I think will need to be. It does solve a lot of other problems. So here is what we have in mind for the Lua. I'm leaving specific details out of each of these, but we are going to do what is written. If that makes sense. I might change the name of some things. We might change some of the interfaces around a little bit, but the functionality is something that we're going to be planning to put into 2611. So that's a November release. It should hit before that. You'll be able to see it in our master branches if you really, really want to. I was thinking the key thing is that, we point out it's Lua based. It's going to be stackable. This is a little different. So people may have experience with our job submit plugin today. Our job submit plugin is stackable, but once you use job submit Lua or Spank Lua, that's it. That's the only Lua plugin you get for that. What's specific design point here is that each HRES can define its own Lua plugin, its own Lua-based plugin. That way, if you've got 5 different QPUs for 5 different vendors, you can create 5 different resources. And each of them can define a separate plugin or a separate instance of the same plugin. So those are key features with this. There's an inline configuration that you can give. Obviously, the plugin could also read its own config file. That adds in some complexity for deployment, but this allows the administrator to, it allows you to set defaults, but also let the administrator control how things are configured on the system. We are integrating user input. I'll show you how that works in a little bit. But the idea there is if you needed to get some, whatever people are doing with Bioscience QPU today, we're adding an inline argument capability that you'll be able to use. This is a key one. This is a maintenance hook. Now it is a polling based one. So there'll be a callback. It's called every n seconds where you get to configure n. I wouldn't recommend making it every second, and it probably wouldn't fire that fast, but you could probably make it every 10 seconds or 30. I'd like to know what would be a reasonable frequency. But the interesting thing about this maintenance hook is that this is the only part of the spec that's able to write the Lua to the HRES interface. And the only thing it can do is change the available count. Now, this isn't by spoofing used. That was a very clever way of doing it. I very much approve of the way that you approach that. But this will allow us to say, no, the available license is going down to 0. And so that way you can, and that way it doesn't manipulate the administrator set configuration.
Yeah.
Oh,
Claudio,
go for it. Sorry.
Yeah, no worries. How does the HRES we interact with all the scheduling phases? For example, the scheduling, the execution, and so on. We will be able to interact with all those phases, or just the execution?
So HRES is a license that is built into scheduling today. So you're able to get very detailed scheduling behavior with it. This includes both backfill and preemption, although you can only use either backfill or preemption. They get a little bit nonsensical if you use both at the same time.
What is the plan to work around the licensing issues and the distribution issues that you mentioned?
Lua sidesteps them all.
But still, if you don't have enough feature in Lua, you would need to change or to create something else, to distribute something else, right? Or change the
Install the appropriate Lua library, yes.
Yeah, we acknowledge that.
Yep.
Okay,
But,
thank you.
Yep.
And I do have one for myself,
Go for it.
and I want to understand from the community's perspective here. I mean, the way you're presenting it, it's coming across that, you would make a separate plugin for each, QPU type, which would, as opposed to perhaps delegating that to the underlying interface.
I think that so here's what I saw today. And I know that is the fundamental goal of openQSE to make a standardized interface plan. That's awesome. That said, I saw 3 different interfaces presented today, each of which talking about 3 different Slurm integrations. So, and I'm aware of several more in the world. So, so I'm trying, I think that it is fantastic, exactly what the community should do to build a standardized thing. That said, I also think this community is moving so quickly that there's going to be a larger degree of fragmentation. And so what I'm focusing on is building a tool set that people can use. And staying out of the details of which one's the right one.
What did you mean by plug-in for each QPU?
So like here, I was thinking it's like statically. It's implying that there'll be an HRS plugin for, you know, mirroring backend you may want to expose.
Oh,
So it gives you that flexibility. Now, you could have multiple instances of the same plugin.
Yeah.
So if you have 5 different varying systems all following a standardized plugin interface, then you get to instantiate 5 copies of the same thing.
Yeah. I mean, I'm specifically bringing it up because, you know, I'm using what we've done with GPU. So what we want to provide generic access to Intel, AMD, and NVIDIA GPUs in our products. We have a common library that manages that because my company has 3 workload managers. We only want 1 library dealing with that. And then it exposes a unified interface, each of our workload managers, which then have to map it to their internal abstractions for managing resources. So you guys can do the same thing with openQSE, making the library. If you didn't, we would likely make our own. So that we didn't have to do multiple plugins for each backend for each workload manager. Because this problem's 9 times as big for us.
So I'm just gonna keep driving forward with
Yeah.
the maintenance hook. So,
hear about that.
yes, but the key thing with the maintenance hook that I wanted to point out is that this is something that can be used to control the availability. But the other thing that is built in is depending on how you return from the maintenance hook, it can either do nothing other than setting perhaps things to 0 or returning them, but it could also say, no, the jobs that are running can't be running anymore. It can terminate all the jobs or requeue all the jobs that are currently running with the HRS.
Oh, so they can call the execution.
It can stop it.
and stuff, yeah.
Yeah, so that way, if you identify, okay, well, this needs to be recalibrated, the runs that are on there are not stable anymore.
Oh, this is.
You can decide to requeue them so it dies. It can't go back in history and undo things that have already finished, but controller pre-run hook. My idea for this, so in general, in terms of an overall sort of flow through the system, I'm just going to fast forward slightly. There's a pre-run hook, and we're just going to say for the moment that it generates payload. That payload can be used by later stages. We'll talk about why that's potentially useful in a minute. Once you get onto as many nodes as are running, so if somebody allocated 500 nodes that all needed to interact with 1 QPU or many QPUs, this would run on all 500 nodes or 1 nodes or whatever was appropriate for the job shape. We have a node level prologue hook and a node level epilogue hook. This could be used, for example, to start a service that interacts with the QPU and tear down the service at the end of the job that interacts with the QPU. Or whatever node level configuration needs to be done to talk to the QPU right now for this instance. Similar, there's a task level prologue and an epilogue hook. This is where you could control them specific to the task, like setting up environment variables or other kinds of integrations. This is, largely basically looking at what other people have needed, and so I'm following along with that.
I have a question about the controller pre-run, but actually it's for Canada. Is that equivalent to the run job?
So this is after it schedules, but before it allocates. But you could prevent it from running at that point.
Yeah, right. Sounds the same.
Okay, so
It's
then
effectively.
okay.
Yeah. Because
I didn't know about that, just to be clear. I just.
Yeah. Sounds the same. Yes.
Okay, because as Matani-san was explaining before, we can use that instead of the maintenance server. As long as we know that the run job gets reevaluated at each scheduling cycle, does that get reevaluated each scheduling cycle?
No, this gets
Oh, okay, so
reevaluated
it's-
once we decided that can schedule is when this runs. I would personally avoid that because at least in part, this will start while lots are held. This runs separate. If you put this into a tight scheduling loop, if this is sufficiently busy, like Frontier,
Sure.
Frontier.
Have a scalability issue, yeah.
So I would not recommend, I would recommend something quick. So I'll show you what I have in mind for this, but basically the thought here, and we won't be holding write locks to the job, so it shouldn't be too bad.
Really considering like how many jobs per scheduling cycle you'll be dispatching. That would be, valid for execution.
Okay, and then finally, there's a post-run hook at the end of everything. Now, so here's what I have in mind. So here's sort of an example. God, I hope this is readable up here. I'm sorry. So what's in black here is an example of a valid HRES configuration today. What I've added in blue is what we are not promising the exact syntax of, but the type of features that we're adding for HRES plugins, which would be that you would define a plugin configuration, path to wherever it is, whatever arguments the user might need to provide or to use it, whether or not they're required or not, whether or not there's a default or not, configuration that's useful. So I'm specifically avoiding putting actual secrets in here, but putting a reference as a leading example of, well, here's the vault where you could get the secret and the name of the secret, and configuration for the maintenance timeout. And so then the S bash now looks like this: S bash minus resources equals QPU1, and I want one of them. And then if there were parameters that need to be included, to bracket it off. So we avoid now any kind of collision between multiple things while trying to use the same interface, because the arguments are now scoped to the specific resource that is being requested. This is actual, almost correct Lua. I just noticed I left off a local, whatever. But this is the kind of, I'm going to use these code snippets to tell a story of how somebody might use this. So this is an example of a maintenance hook. You might go hit the HTTP health Z URL for your REST API. And I would recommend a whole lot more error checking. I just brought this down to, if it was 200, it must be great. But whatever. If it was great, then we're going to set the layer availability to nominal. If it was not great, we're going to set it to 0. So super simple. And in this case, I didn't put a return coding because I think I forgot about the details of that in this example. But if you returned with a negative status and error status, it would cancel the jobs or requeue the jobs. Similar for the pre-run hook. So here's what I have in mind for this, is that one of the big problems that people have in general with dealing with RESTful objects at the end of a wire, at the end of their 2-week long in the queue, is that now you've been forced as an administrator to make a bad choice. Either the job is going, either I'm going to try to guess how long tokens need to stay viable, and I'm going to let users get month-long tokens, or I'm going to make them infinite, or I'm going to let jobs fail. I basically left a lot of bad choices. So my concept for the pre-run hook here and why it's generating a payload is that this is a place where you could pre-configure the QPU or whatever other external device to get a token that is now, scoped to where the job is going to run and how long it's going to run for. So that gives you the opportunity to sort of securely deal with this. It was fine for this job to be sitting in the queue for this long, but now it needs to run and get a fresh authorization. Similarly, now that payload shows up in your prologue, I use that to start a service. I calculated a socket path that I wanted for Unix domain socket. I'm just using that because I like Unix domain sockets, because now I can move those around as files, inject them into containers very, very easily to sort of get very flexible communication around. And so then now the nice thing is, now if I set an environment variable, we've already given the token for example, in this made up example. I have no idea if any of these layers look like this, but in my mind, this is how they might look. This avoids me having to put any secrets out in the environment. And it's the same thing at the end. There was no task up below. It's just nonsense. And so then we just tear down the service at the end. So that's a very basic example. So now we sort of go back to this. So this means now that my interactions with the logical QPU from a job perspective are during pre-run to get that authorization. Once we get into node allocation, the prologue runs. The task finally gets to use it. That's the big bold line. And then at the very end, the post run can then tear down that credential. So that way it's not scoped for longer than it needs to. That's the general model that I have. There are opportunities for feedback now. Now, number one, one of the things that we didn't talk about, and this doesn't work today, but it's something that we've been doing a lot of with our Kubernetes bridging, our Slurm bridge to Kubernetes, has been a concept of external jobs. So one of the ideas, and I'm not committing to this for 2611 no matter what, but it's something that we could build on, and an example of areas that we could build towards, is that it could be really interesting in my mind to start an external job with QPU, meaning, number one, you could potentially represent in Slurm all those jobs that are coming in from cloud, one. Number two, you could also, so that's where I was asking, would there be feedback coming in from that other scheduler through these interfaces? And do I need to provide some kind of endpoint? Number two, you could potentially imagine that I have a transpiler job, and then I have my QPU job, but I'm not actually going to use any actual, I'm just going to run the job and let it do whatever it's going to do. And so I can tell Slurm, go run that job, and the plugin can actually do the actual heavy lifting. We don't allocate any compute nodes. And then finally, there's an analysis job. So I was curious if people are interested in using Slurm with these external node capability, external job capabilities to represent things that actually aren't running on the system, but need to be part of the workflow dependency chain.
Yeah. No, I think as a general concept, that's what I want.
Yeah, I think it's exciting, but I don't know how, it's like I say, it's not scope for this cycle, but it's something I could easily imagine being useful.
I definitely see it coming, but right now, most of the quantum HPC workloads are kind of stitched together manually. Right. But I definitely see it coming. Yeah.
And I think something that came up this morning that is not something that Slurm necessarily has any ability to deal with, but I want to think about if there is an enhancement that we need to make to Slurm. I have some ideas in this regard. Some of the other features that I'm not going to talk about today might weigh in on this, but I'm thinking about the requirement that you gave that I ran a transpilation job, but the execution job hasn't run yet. And now we have to recalibrate. And it would be very interesting if the plugin could interact and at least flag up all those transpilation jobs that now become decayed. Or at the very least, maybe the plugin doesn't need to, but we need the metadata somehow involved. So I think that was one thing I learned today. And then, so anyway, I wanted to make sure that this is the workflow that I have in mind. So transpilation followed by execution followed by post-processing. And I want to know if there are others. What else?
Actually, the person following you. Awesome. Yeah, well, yeah.
Great. And then so finally, I also, I wanted to point out that we have some ability to do accounting with these HRES today. It is by using the licensed word, even though it's an HRES. But I know that there's a lot of interest in getting more detailed on this. I would like that as well. I don't know what to build that would expose this. I have ideas, but I haven't put it in the spec that I'm committing to yet. But things like perhaps that task epilogue, you could have the plugin go get the usage from this compute node, and there could be some sort of simple reduce operation that comes back. But like I said, I'm not committing to any of that right now because I want to know what we actually need before I build it.
Maybe a trivial question. So on the usage and accounting thing, how difficult it is to pass a Slurm identifier to the quantum system so that it can show up in quantum telemetries, for example?
What do you mean?
The reason, so for example, like you run a job on a device. Usually when people do the analysis, they want to correlate what ran on a certain time period to a particular job that was submitted. So to do that later on, you need a key to kind of associate those things.
It's not too bad because after this point, all the hooks that run after this point will all have a job record. And so the plugin could easily take anything under that job record that it finds useful. For example, that job ID.
And then that can be paid for to the, so the plugin can just utilize that as well.
My view is that I need to know the data that needs to be available to the plugin so the plugin can do its job. But that is data I've already anticipated you would need, but I would say that it's the plugin's job to do something exciting with it.
They said this will be released November.
The things I have written down with the strong proviso that the exact syntax or names of things might change, but the functionality that I described is coming in November. And then, yeah, this is just basically me summarizing that we're trying to build something generic that supports all manner of external devices. I think one of the things that is interesting, one of the people talk about tight integration with QPUs, and I'm still struggling to decide what that means. In my mind, it means cons res level integration. And so that was a question that I also have is, what would it mean for a scheduler or a workload manager to be tightly integrated with the QPU?
Depends on.
Does this mean it? Just
So, for example, when you talk to the QEC people, they're talking about like tight latency requirements, right, to do the
right.
quantum error correction. I don't think we have. Would you say we have tight application level requirements yet? You think we do see that? Yeah. Okay. So it's possible that that's a requirement as well.
Well, that's what I want to understand what that means. And that's that. Any other questions? And also I'm available to discuss as much as you want.
Questions for Doug?
To figure out how to stop sharing so we can move on to the next one.
Yeah, but maybe one more meta question. Would you be willing to have more regular discussions
Yeah.
with the community?
Of course.
Okay.